So, charts and graphs. We're going to talk about the different types of charts we can present and generate in Excel. And really, when I say chart, graph, to me it means the same thing. I'll use these interchangeably. Um, Charts and graphs are different than tables. Tables are tabular lists of numbers with rows and columns. Graphs and charts really are graphical representations of a lot of times tables. And so if we look at the fundamental problem-solving cycle, we're really encompassing the analysis and especially the communication part when we deal with charts and graphs. So this is where we take the analysis we've done and we present it graphically. This is a very key part of problem solving. When we communicate our results, we need to do it in a way that is clear to the audience or to the reader or viewer, and also hopefully allowing them to just see the result jump off the page. So we're going to go through a couple different types of graphs and when we would use different ones. This is very important. There are different charts for different purposes, of course, and depending on our data or what we're trying to represent is really going to drive how we represent that with what chart. So first, bar or column charts. These are very common and they indicate quantities. So whenever we want to say how much of something, right, we want to use a bar chart. So we have different items here, A, B, C, D, and we're just representing the different quantities of the A, B, C, or D things. We have an ability to use different colors and maybe have different sections or subsections of A or B. But really, predominantly what we're trying to do is the quantity of different things. So how many A's, how many B's, how many C's, how many D's, right? And we can compare those and we can see, the larger ones and the smaller ones. Line or scatter charts. So in Excel, you will see this referred to as a scatter chart, and also line charts. But scatter charts specifically allow us to add trend lines, and this allows us to see trends. Surprise, surprise, trends in the data. So if we want to represent our data graphically and show, over time or based on some type of trend, what's happening on average with the data, we can do that. So jumping back to line charts, a line chart just being, we have a line running through the different data points that we have, and so these are our data points and we've just connected them with a line. And this can show, the increasing values or quantities, or in this case speed based on time, right? But if we want to show the trend in the data, this is actually a little bit different. Trend lines are where you take your data points and you throw them into a mathematical model and you come out with an equation that represents on average your data. Okay, so you can actually interpret or predict the different values that you may have based on different time frame. Okay, so we'll look at that in a little more detail in our Excel example, but understand that scatter charts have the ability to have trend lines. Okay, so this scatter chart here on the right, here's our data, and if we were to draw lines across it, it would be all over the place, right? And that would look just as busy as all the dots. But what a trend line will do for us, maybe I'll get a different color here. Well, it's not showing up. What a trend line will do for us is it will draw a line through the middle of that data. And it will also allow us to have an equation that goes along with that line. So that we could say on average, you're going to have some above and below, but on average, if you're at a quiz average of 80, you're probably going to have a final score of 65 or so. Okay, this allows us to kind of calculate the middle point of all these data and come up with an equation. Now, some data will lie very close to that line. Some data will be far away, right? And of course, this data is less well fit or represented by that line compared to this data, right? And so some of the data will be very close, and we'll be able to predict or calculate those values very, very well with very little error. Some values will be far away, and there'll be more error compared to that line. And so this really, trend lines and putting a trend line through data gives us an equation, but there's always some error related to that, right? Because it's not going to be perfect for all the data points. And there's a term called R squared, which we can calculate when we do the trend line to tell us how well the data matches or fits that trend line, and vice versa. And what that allows us to say is, this trend line is a good fit or a very good representation of the data, or it's not a very good fit or representation of the data. Okay, good fitted data has R values of +1. Okay, and of course, the worse you go, the further down you go. Okay, and we'll see this in Excel. But ideally, we're trying to get as close to +1 as we can. And we can have different types of trend lines: linear, exponential, polynomial. So we have an option to select different types of trend lines. And what we're going to try and do with those trend lines is pick one that makes the R-square value as close to 1 as practically possible. And we'll talk about what that word practically possible means. But what we're trying to do is we're trying to represent our data, which is all over the place, with a simpler trend line that has an equation something like y equals 1x minus 0.5 maybe. Okay, so every time we have our x values along the bottom, we'll put that into the equation, subtract 0.5, we get our y values along the left axis. Okay, and so this allows us then to calculate based on what our x is, what our y will be. So pie charts. Pie charts now look like a pie, right? They indicate pieces of the total. Okay, and a lot of times we use this to represent percentages or how much of the total, right? I just said that, of course. Each different category is. And one thing that's important to remember when you do a pie chart is that you do need to show the total. Okay, they should all equal the total or all add up to 100%. Okay, and that's important because if it doesn't, then you're going to an improper representation of each of the categories. Okay, and so we have a pie chart here. We can have them kind of exploding out if we want. We don't have to have them exploding. We can have the key here. We can have the values next to it. But key pieces that indicating pieces of the total. Okay, just like pieces of a pie. Pareto charts. These are a specific type of bar chart that help us indicate the significant few from the insignificant many. So the significant few, a lot of times when we have issues in quality or issues with cost, we can categorize different issues and chart them from the biggest or most commonly occurring issues down to the least occurring issues. And what we find with the Pareto chart, and it's really a Pareto principle or rule of thumb, that usually the top couple account for 80% of the total money or waste. Okay, and that leaves the rest, the insignificant many, that account for the rest of the 20%. So an example is a lot of times helpful. Here we have a Pareto chart of problems downloading files, and we have all different categories of things that are problems in downloading. And we see that unable to download, just broadly unable to download, was the biggest issue, single item, and that happened close to 50 times. Then you can't find the file, happened roughly 30 times, followed by opens as a read-only, which happened, we're going to say 15 times, okay? Followed by all these other ones, right? With didn't have Excel, doesn't work in OpenOffice, is happening very, very few, maybe 1 or 2 times each. And what this does, when we order these largest down to smallest, okay, that's important, we say that the top 3, okay, if we add the cumulative percentage, so this 50 divided by the total number, okay, plus that percentage plus this percentage of the total, right? And we add these cumulatively, we get this increasing up to 100%, okay? The point at which we have these top 3, okay, they account for over 80% of the total issues with this process, okay? So in other words, there's only a couple things that really account for most of the issue, okay? And that's what a Pareto chart will allow us to do. It allows us to identify the 1 or 2 or 3 things, or 4 things, that account for roughly 80% of the issues, or cost, or waste, right? And all the other things, right, all these other things that hardly ever happen, those are insignificant. We don't want to waste our time dealing with those because they don't really account for hardly any of the total issue. It's really these top 3 here that are the significant few, okay? And those are the things we want to spend our time analyzing and coming up with alternate solutions to mitigate those issues. Okay, so Pareto charts, really what we're trying to do is we're trying to look at the significant few things, a couple things that account for roughly 80% of the issues, or cost, or waste. And we don't care about all the other ones, okay, because they hardly make any difference relative to all the other ones. Frequency or histogram charts. These are also similar to bar charts but have a nuance to them. Okay, and the nuance is that these are used when we want to indicate how often something happens. Okay, so not only how much of each category, but how often. Okay, frequency. And a lot of times we can visualize this as a bell curve, or exam grades, or test grades, or quiz grades in a class. And of course we have along the bottom here the points on the quiz. Okay, so up to 100 points. And with how many students scored each range of points. Okay. Of course, the thing we see from this is that it's basically a bell curve, right, as we expect or hope to expect. And most students, over 50 students, scored between a 50 to 60. Okay, so that's almost the median or average of the student class. And roughly 30 students, just under 30 students, scored 30 to 40, with 20 students scoring 70 to 80, right? So this is showing how many students had the scores in these different ranges, okay? And so that helps us see the distribution or the frequency of how often we had different scores in those different ranges, okay? So frequency, histogram, distribution, those all mean very similar things to me. And in the class, we'll talk about those almost interchangeably. But it's important to understand that we have different ranges along the bottom, okay? And each time we count how many times something has happened in those different ranges. Another thing we could have is temperatures, right? So we have different temperatures here, and we have how often or how many days of the year we had temperatures in the 50 to 60 range, 70 to 80 range, right? And we can see a distribution or frequency of temperature ranges. Okay, we're going to switch gears real quick before we go to Excel. And we're talking about writing words to analyze our data. When we write conclusions, you need to explain your data with clear references to charts and tables. So if we say our solution is X, Y, Z, we should also follow that with a couple words that sound like based on table B or based on chart C. Okay, we want to draw clear and concise relationships or links to the data to our solution. So why are we concluding what we're concluding, or why is our solution the way it is? Because of this table or this graph. Okay, we also want to, when we're looking at data and graphs, it's really helpful to compare and contrast. Okay, that's where we really see the meaningful things that come out of our data. We also want to hint at maybe a deeper meaning. What does the differences mean, right? Or what do the similarities mean? Temperatures in this state are much wider in range than temperatures in the other state. What does that mean? Maybe the first state is more of a desert type of a region where the temperatures fluctuate a lot more. And the second state maybe is closer to the ocean, so it has a more of a common temperature range. Also want to hint at what's still unknown, right? Some things in our data that maybe we don't understand, but we know that there's something there that maybe needs a further solution to, and that's fine. We can come to a conclusion and say we found X, but we don't understand Y, and that needs to be looked at in the future. Another big part of this, data should validate your written conclusions. Okay, so like we talked about up here, we draw links to our data, to our conclusions. It really helps us prove what we're saying is data driven. Okay. Also, data gives us that snapshot. We can't show all the data, okay, but we can show a snapshot or a graph, right, that shows the really key parts or the thing about the data or a few things that we really want to show the reader or the audience that helps solidify why we're deciding or concluding what we're concluding. And of course, it's a good summary, right? It's a snapshot and a summary. Those are kind of synonymous things, right? And so when you're writing your write-ups and your conclusions, really try and remember to link them to the data, okay? And to show a nice clean graphic or graph or table that really allows the data to jump off the page and help that reader see that clearly. So we're going to look at Excel. We're going to look at specifically histograms, Pareto charts, and trend lines. So over here I have a file here that you'll have on Blackboard. You can open this up if you haven't already. But this will just run through a few examples of some tables or charts that we just talked about. And basically this, on the first tab here, we have a table of natural gas imported countries and export countries, right? And this is in billion cubic feet, okay? So over all these different months and years, we've had these different sizes of imports and exports from these different countries. And I think we have here Canada and Trinidad and Tobago and the total. Exports, Canada, Mexico, total. Okay, so we have 2 imports, total imports, 2 export countries, total exports. And of course, these go down a number of years. So we can come in here and we can make histograms of these different items. And so we could say, let's go in and let's look at Canada and across all of these days and months. And let's look at inserting a recommended chart. And of course, it shows a couple different things here, but I really want to just go down to histograms here. Click on histograms and pull that up. And so remember we said that a histogram is a list of charts showing the frequencies of how often something happens. And so we see that a very common, the most common per month import quantity was between 223 and change and 200 and almost 50 and change. Okay, with trailing off up to 350 and really sharply falling off to below 223. Okay, so we could leave it at that, but we're going to want to actually put in, we could double click in here. Canada imports. We could put in here, we can change some of the axes if we want. We would maybe want to click on here, click on the chart, and we could add axis titles. Okay, that could be helpful. And so double click on the titles and say maybe per month frequency, or maybe just simply frequency. That's what this is, frequency. And of course down here we would say per month, per month quantity, QTY. Okay, now we can also change the range of these columns. So we could say, well, I don't want this goofy range, right? That's kind of a hard numbers to kind of visualize and look at. So we can come in here and we can say, we double click. Okay, so if we close this, we're back here, and double click on this, and we can actually do bin width. Okay, so those are the bins, or these, the size of the first starting number and the ending number, right? And we could come in here and it's, right now it's 26. Okay, I could make this 20. Enter. Okay, and it would change that, right? It would change how many there are because I've now made these smaller. I could make this 10. Okay, and change it even more. I could also do number of bins. Okay, so I could say I don't care how wide they are, I just want to say there's 10 of them or there's 12 of them. I can do this. What I would recommend is that a rule of thumb is that anywhere from 5 to 10, with roughly 7 or 8 usually being a good way to represent your data. And this is going to think here. Okay, you just don't want it to have too many or too few, right? Too few, you don't really see very much distinction between the different ranges or bins. Too many, and you're just giving the viewer too much information to look at. So somewhere in between, maybe 8 seemed like a good number. Okay. You could also, maybe once you get the 8, you could say, well, let's get a nicer number here. Let's get more of a round number, maybe 16, right? An easier number to look at. We can also come in here and look at text options. If you wanted to change things there. But usually we're gonna play with this bin size or number of bins. And we can also come down here and we can format these as a number, and we can also say, let's do, I believe this will work, yeah, 0 decimal places. So that even makes it cleaner, more easy to see the ranges and get rid of those decimal values. Okay, so that's some things we can do with generating a histogram. This is actually a very recent functionality in Excel 2016. We could not do this in 2013 version of Excel. So this is actually very, very, very much more easy, much easier to do and to modify those bins than before. Okay, so now let's look at Pareto charts. So I've pulled over a couple different countries here, and this is the billion cubic feet. So these are imports, and I've listed Canada here, China here, Canada here, right? And I want to show a Pareto chart. So I want to see what are the couple that are most important or significant, and what are all the other ones that aren't as significant. So I can come across and select those cells, okay, the countries and the quantities with the header. And of course I can go back to insert, recommended, And next to histogram, there's actually a Pareto. Okay, so I can again click that. And just like that, we have the counts, right, and then the cumulative percent on the right axis or the secondary axis, and we have the counts on the primary or left axis. Okay, again, we can add axis titles and can fill those out. We can add the chart title. It's important to add titles to our axes so that we know, especially over here on the left axis, what is the unit. Okay, 14,000 what? Okay, we know there's 14,000 billion cubic feet. Okay, so we want to say maybe billion cubic feet, right, in here. We can also come in here and say mins and maxes if we want the maximum to be higher, right? It'll auto to what looks nice, but we could change this to 20,000 if we wanted, right? And just push that down. Same thing on our percentage axis. We can do those types of things. We could also change the formatting of this, right? So just like before, all different types of formatting here. Basically, you just need to double click on the item that you want to format, and it'll pop up on the right side here of how to do that or where to do that. So that's our Pareto chart. Okay, very quick and easy. Just have to select the data. Trend lines. Okay, trend lines allow us to show trends in the data, right? So we have different times. We have growth number of cells, decay number of cells. Let's look at these two columns. So every so many hours, right, we're going to count the number of cells that have grown in a biological process. Okay, so we're growing cells, and we want to plot how many and the trend and how many grow based on the time. So we select that data. I can also come down here and click on this quick analysis. Either just hover over it or do Control Q. And I can come over here to charts, and I'll do scatter, because remember, scatter allows us to do the trend line. I have my scatter chart here, and I can come into design, okay, and I can select even maybe a little different option here, maybe without the lines, because I want to put a trend line. I'll just go with the dots, okay, because then my trend line won't be as confusing with the other line. So there I have my data points, and so after so much time, you slowly start to exponentially increase. So what I want to do is I want to add trend line, and I'm going to go to more options, okay, because I want to get some different options of trend lines to use. I have exponential, logarithmic, polynomial, etc. Now before I do that, I'm going to scroll down here and say display equation. Okay, so that's the equation for that line. Also display r squared, right? We talked about r squared, okay, being how well our data fits this line, okay, kind of how much error is there. Okay, so close to 1 is what we want. Closer to 0 we don't want. So if I come in here with a linear, that r square is 0.39, okay, not very close to 1. But if I come in here and I say, let's change to exponential, all of a sudden that changes to 0.99. What about logarithmic? Well, that's terrible, right? Of course it's not logarithmic. What about polynomial? 0.735. I can add orders of polynomial, so x squared, x cubed, x to the fourth, right? X to the fifth. And as I do this, of course, I'm getting closer and closer to 1. But at some point, if you do this, especially the polynomial, you'll start to, at the first couple polynomial orders you add, you'll jump a lot in percentage, okay, from 0.73 to 0.91, and then you start trailing off, right? 90 is 0.97, pretty close to 0.99, 0.99 is very close to 0.999, right? So at some point, you're going to trail off with how much that r squared changes. So here's where the real world application comes. The more orders of a polynomial you add, the crazier that equation gets, right? So what a common practice is to do is look at this r squared as you add orders of polynomial, and really you're looking for where does it stop increasing drastically. Okay, so I would say that increases drastically. That increases pretty good, but anywhere between 4 and 5 and 6, right? You're really diminishing how much you increase in that r squared. So I would say somewhere between 3 and 4. Maybe you could make the argument that 4 is a good one because 97 is a little bit better than 93. So I would stop there. Okay, it's a little bit of a crazy equation, but the data fits or is closer to that. Let's get this trend line out of the way. The data is closer to this trend line here, right, than if we had 3, right? There's some places where it's not quite close to the data. So that's what I would do with the trend line, okay? So that's how we can put a trend line in here. Of course, maybe even easier, like we initially saw, is an exponential, okay? And that's a 9, 9, okay? That's almost 1, right? So that's even better than we were with a much simpler equation. And we can make this text larger if we want here. We can go to Home, and we can go to Text Size, and we can increase that to see that better. So the last thing we'll do is, well, we did histograms already. Yep, so that was it. That's it. So trend lines, Pareto charts, and histograms. Okay, so some of the key charts that we'll actually be using in this class that will help us really get at the underlying themes in our data. And trend line is a very important one because it allows us to show a trend with an equation. Okay, so we could say every day X, you increase, right? You put that into the equation, you'll get out a Y number of cells. Okay. One more thing we could show, maybe to make this even simpler to represent, is we could show this not as a linear axis, but as an exponential axis. So we could come in here and we could say select this axis and go to logarithmic. Okay. And what that does is he says 1, 10, 100, 1,000, 10,000, right? So that in essence flattens our line out. Our equation stays the same, okay? But visually our line flattens out. Whether this is helpful for you to understand, possibly it kind of allows the first couple days here to be able to be more distinguishable. But we got to be careful that we understand that the left axis here is a logarithmic. It's not just a linear. Okay, it's non-linear. Okay, so that's all I want to cover here. We'll get to some of this stuff in class. I'll see you then.